Right, well, welcome back to yet another video from Bell the UCAT. So, sorry, it's been a while. Here we are. So, well, season is right around the corner, which is prepping. I'm sure everybody would have started prepping for UCAT. And thank you very much for all the emails about everything courses. Some of us have been registered, and the courses are just about to go live right about early end of not end of May. Sorry, it's just been a bit of a delay, technical issues and whatnot. Well, forget about the rant. Right, so firstly, about the emails, when people talk about, oh right, you ask them, how's your prep going on? So when they talk about prep, or when they discuss their performance in any of those mock tests that we've asked them to do, that will just for those students who've applied for the comprehensive UCAT course. Right, so there was a consultation, so in which what I generally see a pattern, not this time, but almost every single time. You ask them, how's verbal reasoning? Well, verbal reasoning, no matter how much you try, right. There is a limitation factor, right, in verbal reasoning. Well, if that's any consolation, just to let you know, throughout the last 10, 12 years of UCAT, I've looked at the stats, verbal reasoning has always been the worst of all the sections, in which the average mean score, verbal reasoning, has always been low, right? The exception is always there, right? Oh, so somebody, if you ask somebody, verbal reasoning, you say, well, right, I'm just doing just about fine. Verbal reasoning is good, okay. Decision making, oh wow, it's a mix of all different styles of questions. Now, the key thing which we are talking about today is quantitative reasoning. When they talk about quantitative reasoning, I ask them, how is it going on? So, well, they say, well, quantitative reasoning is fine, absolutely fine, till they end up smashing or attempting the tests, which is a subsection test. Now you need to crack 36 questions in 26 minutes. You do the maths. That means roughly you got around, speedy maths, 43 seconds or thereabouts to crack every single question. Now, but that's not the challenge. The challenge is majority of the students who attack these 36 questions, shockingly, they're only able to see, view, attempt only 20. I'll repeat. Shockingly, in my courses which I do, I talk about something called the hit ratio. So what is hit ratio? Hit ratio is something about how many questions you attempt, see, view. Now, the problem is, out of those hit ratio, out of the 36 questions, people are only able to see, view, and attempt no more than 20. Those of us who've just started UCAT prep or right in the middle of UCAT prep. So you need to pump up your hit ratio. Why? Let's suppose this particular student in question, somebody at random, hypothetical, hypothesis testing, those of us who are doing maths, stats, right, 20 out of 36 is on 20 questions attempted, viewed, or seen these questions. Let's suppose that person, right now, that person's hit ratio is somewhere around 55.5% or thereabouts 55. Okay, that's fine. That's a very low hit ratio. Now, let's suppose out of the 20 questions that particular student attempted, he or she, let's give him or her the benefit of doubt, has got 80% accuracy. With 80% accuracy, 80% of the 20 means that person's only getting 16 out of 36. That is well below par. You won't be able to get more than 600 out of the 900 that you're looking at. So that's the big dilemma. That means rule number one, I need to pump up my hit ratio. How much? When you are performing, your aim and goal should be, if you need to attack, view, see, attempt all 36 questions. That's right, including some of those you skip it. So you should have the ability to view, see, attempt all the 36 questions. Now let's suppose a person says, all right, out of the 36 questions, I skipped maybe 6 of them, just randomly to give us a... That means that person has seen, viewed, attempted all the 36 questions, perhaps skipped 6. Let's suppose we're giving that person 80%. Accuracy. If we're giving that person 80% accuracy, you're looking at that person ended up getting 24 out of 36, which pushes that person in round about 670 out of 900 score. Ready? Okay. So how do we get to that? So anything above to 27 in the courses that I do, I talk about your target score should be nothing less than 27. If you are to crack and smash this quant section of UCAT. So how do I get to 27 plus score? That's how you will end up hitting 700 plus. You need to get 700. No matter what people say, anything above 700 in or rather should I say, an average score of 700 in all the sections throughout. I'm not talking about situational judgment. Out of the 3 sections, your average score should be in 700 plus if you're really seriously serious about cracking this particular UCAT. Right, so 27, how do I get it? First, warning. The solutions offered by UCAT when we do a question and so on, which we'll see, are very, should I say, most of them, the tricky ones, are very conventional GCSE ways of doing it, but that's not how we need to attempt it. Medify, Med-Entry, they give you solutions which are GCSE. Sadly, we cannot use GCSE because they are time suckers. I want to be able to do a question in less than 43 seconds because 36 questions in 26 minutes. So we're looking at 43 seconds a question. Ready? So how do I do it? Speedy math, shortcuts, unconventional ways, because this is not GCSE A-level where working is needed. I should be able to crack it. Right, without further ado, let's get cracking. Where am I? I am on the UCAT website trying to crack a few more questions. What section? Here I'm on section number 4, section 4 of the quantitative reasoning. How do I get it? I got here on by hitting navigator, quantitative reasoning. Here I am. Ready? All right, let's see if you can crack a few more questions. Speed is the name of the game. Right, question number 1, numero uno. Here we go. Right, helium balloon, blah, 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 was used, okay. And once it's used, right, below is information, temperature, and so on. Right, so we've got the temperature, balloons change in atmosphere, height, and how fast the balloons. So there's dry air, there's wet air, rate, which is meters per second, that's speed. Unit conversion, I should know the top of my head, 1 mile equals 1.6 kilometers or 1,600 meters. Ready? Okay, so what is on? The ground temperature is 24 degrees Celsius. What is the temperature in dry air? So that means I'm talking about dry air here. At a height of 1,000. Right, so what am I doing? I'm going from ground, strategy number 1. Whatever is changing, so you're going from ground, which is 0 meters, to 1,800 meters. So whatever is changing, which is ground, temperature is changing, whatever is changing, this scenario, ground is changing. So I need to find how much is for per unit of that. If the ground is changing, per meter. If temperature is changing, per degree Celsius, per Kelvin, chemistry. Right, so if ground temperature is changing, ground is changing. Oh, height is changing. Height is changing. All right, let me find out how much it is. How much it is, which is 5.2, is what the name of the game is. So I will divide, which is find out the change in temperature per meter. So what will I do? Oh, you could do it in your head. 5.2 divide by, do I have 500? That is for every 1 meter, how much is changing? All right, second tip. Whenever you divide by 5, you double the top number. Right, so that would be 0.0104. Double of 52, 104. Bang, got it. Right, just to prove it to you. So I'm doing 5.2 divided by 500. Bang, 0.104. What is that? That is a change of temperature altogether per meter. How many meters am I looking at? Oh yes, he's talking about 1,800 meters. Right, can I times it by 1,800? So I've got 18.72 is what is altogether temperature will change. Right, how much was initial temperature? 24. How much is it change? 5.28. Bang, 5.28. 5.3 is my answer. Option A. Easy. Right, okay, quickly running through this one more time. What's the name of the game? The name of the game here is I'm trying to find out the temperature. All right, who is changing is first thing you look for. That's how I'm actually using ratios, but that just quicken your calculation. So ground, height is changing from ground to 1.8. Oh, whoever is changing, you find 1 unit of that, 1 meter of that. What did I do? Tip number 2, 5.2. I want to define how much is per meter. To find out how much is per meter, divide both sides by GCSE. 5.2 divided by 500. Anything divided by 5, you double the top number and divide by 10. Right, so that makes it 52, double that, 104. That is per meter, that's how much temperature is changing. I want to know how much is for 1,800, so that's what I did. So 0.104, oopsie, 0.0104 times by 1,800, 18.72. Ready? That's the actual change in temperature, 1.8. How much was initial? 24, 5.28. Option A it is. Right, easy peasy. So I've got option A altogether. Ready? And yeah, we're good for option A. Ready, moving on to my next question. What's the next question? The next question talks about, let's spin it. The ball rises in wet air from a ground temperature of 24. How many minutes? Oh, he wants me to find minutes, which is he wants me to find time. Time is equal to, do I have distance over speed? Right, so the balloon rises from temperature, this one, so I'm talking about wet air now. Ready? To nearest temperature is now, the temperature is changing now from 24 to 0 degrees Celsius. If temperature is changing, I will find out how much is per degree Celsius. So I will do 500 divided by 2.8. Do I have 178.5 is for every, so I will end up changing 1 degree Celsius changes for this, right? So what do I want? I want him to go down by 24, right? So I've got, which is 500 divided by 2.8 is what we got, times by, what was the number? 24. 428, that's the total distance. So I've got a distance of 4285, as you see on my calculator. 4285, I will divide by speed. How much is the speed? Speed is 4.8 given to me. This is 4.8. Oh, distance over speed divided by 4.8 is what we've got. And 4.8, answer is 892. Right? That should be none of the... Oh, sorry, that's in seconds. He wants in minutes. Seconds, can I divide by 60? Bravo, 14.88. Option D is what we're looking at. 15 is my answer. Ready? Okay, so are we good? Oh, option D it is. Ready? So one more time, the same thing. What was changing? Temperature changing. I want to find per degree Celsius. Per degree Celsius, how much? So divide both sides by a wet 500 divided by 2.8. So 178 is what is changing for 1 degree Celsius for every 178. So how much do I need? I want him to go down to 24, because 24 to 0 is 24, 4.28. That's the distance traveled. Ready? So sorry, so once we've got that, what's that? Divide by speed, 892. That's in seconds, divided by 60, 148, 14.88, 15. Bravo. Moving on to our next question. Right, so doing well. Okay, there we go. So he's talking about what? A balloon flew on Monday, a second balloon flew on Tuesday, rate of climb of the balloon, second balloon was 25% more. Rate of climb literally means speed. So as we said to you, which of the following must be true? Second balloon, time, everything's talking about time. As we know, time is equal to distance over speed. Right. Clearly, if the speed increases, time has to decrease. Right, that means he's saying 1/20 of the time. That's option out. Option out. My time has to be less. How much less? He says 25% more. It's tip number, whatever, tip number 4 or 5 or 3, I don't know. So 25% more. Oh, it's 1.25. 1.25, you should know by default. 1.25, how much would that be? Oh, that's 80%. Bang. Answer is 80%. Right. So straight away, got 80%. Right, how do you do 80%? So, right, so that is literally, you do 1 divided by 1.25. Bang, 80. Woo! Again, your ability to convert fractions to decimals into fractions, or second way. 1.25, if you agree with me, another way of doing the same question. 1.25 is, 1.25 actually is also equal to 5 over 4. Agree with me? 5 over 4. 5 over 4 of the speed, those of us who do maths would know that can be written down as 4 over 5, which is distance over speed. How much is 4/5? 4/5 is clearly 80%. Anything with an 80%? Oh, yes. 4 over 5 is 80. Again, another one, ability to convert fractions into decimals, decimals into fractions, fractions into percentages, percentages into fractions or decimals. So 80% it is. Option C. Ready? All right. So in here, option C it is. So one more time, because speed is greater, time will decrease. So we eliminated D and E. How much greater? 1.25. Oh, 1 over 1.25. You could have just done 1 divided by 1.25. Oh, see. You could have just done 1 divided by... why is it not? 1 divided by 1.25. 0.8. 80%. Bang. That was the answer. Or 1.25 can be done as 5 over 4. Because I'm explaining, that's why it's taking longer. 4 over 5, 80. Bang. There we go. So that's the second way of doing it. Bravo. Well done. Right. Moving on to my next question. What's the next question here now? The next question we're looking at altogether is this, which is, what is the decreased temperature? Wet air. I'm talking about wet air. Wet air is how much? Fahrenheit per mile. Fahrenheit per mile. I want to find out per mile. 1 mile is, as we know, top of your head, don't need to actually wait. How many 500s? How many 500s are there in 1,600? Divide by 5, you would know it, 3.2. Bang. As we said before, when you divide by 5, you double the top number and divide by 10. So do I have 3.2? 3.2, 500s are there. Times it by 2.8. Bang, 8.96. 8.96 degrees Celsius per mile. This value is 8.96 degrees Celsius per mile. I will times it by just 1.8, 16.12. Bravo, 16.12, 16.1, and so on. Now, some people would say, whoa, 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 wait a minute, you forgot to add the 32. Yes, you're right. I don't need to. Why? Because anytime I'm finding out changes in temperature, I've got F1. I'm using logic of simultaneous equation. F1 is equal to 1.8 C1 plus. Do I have 32 is what we've got. Similarly, F2 is equal to 1.8. Do I have C2 plus 32 is what you've got. Because I'm finding out changes in temperature, there are two variables which are changing. I have to use simultaneous. Do we see 32 goes out, gets eliminated, simultaneous equation. Oh, I just had to do 16.18. Ready? Just not together for cells. Do we have the right answer? Indeed, we do have the right answer. Ouch. Look at the horrible way they have done. That's not how it should be done. That is not how it should be done. Many people would have skipped this question, but actually it was so doable. All I did was, how many 500s are there in 1,600? And with 3.2, I times it by 2.8. 2.8 times by 3.2 is what we've got, 8.96. Ready? Times it by 1.8. Bravo, 16.128. And if you see here, special rule, another trick. And as I say, I could get tired. Many people are kept on asking, could you put more and more examples in all the strategies to make a video? Problem is, I can't. I'll try to make the videos shorter. Thank you very much. I know the request, everybody's saying, can you make the videos longer? There's only a select few people who will watch these long videos. I'm trying to keep it short and brief. Right, I will be uploading most of them. Otherwise, if you want to know more, well, sorry, might sound very business-like. There you go. In the courses that I do, they are very detailed. That's where you got all details of all the strategies, whether that's DM, decision-making, or quants. Ready? Bravo. So that was it. So that's not the way. That's what I was saying. These conventional GCSE ways, this is GCSE way. I can't be doing that in UCAT. Ready? Moving on. Let's do just one more question. Let me just call it a day, and we'll catch you in the next video soon. Right. Okay. So where will we? Right. How many stores does the distribution center serve? Distribution center serve. We just need to add them up. Add them up. There are two ways to add them up. First, add them the last digits, right? So straight away when you see you need to add them up, you look at the options. Right, so there are three options which I've got. Okay, let's see. 3, 5, 8, last digit strategy. There are multiple strategies. So I'm doing the first two, just the common ones. 3 and 5, 8, 8 and 6, 14, last digits, 4, 14, 4 and 6. 0. Oh, three options, 3, 0. Oh, right. Can't be using that. So it can't be 77 because my last digit has to be 0. Last digit strategy. Next, strategy number 2, bunch them up, and that's how you do mental maths. 3 and 5, 15, 18, 18, 26, 44. So you've got 44, 44 plus 36, 80. Oh, yes, has to be option C is what we're looking at. 80, bravo. Right. Righty guys, this is it. We'll catch you in another video. I'll continue later in another video. And keep smashing the UCAT and belling the UCAT. Till then, catch you again. Please feel free to drop me an emails. Any inquiries about courses going live in June. Bravo. Bye-bye. Ciao, ciao.